welcome back. This is my 6th video on elastic collisions in 2D. Here's a question, give it a go and come back when you're ready. Right, so we know that the coefficient of restitution between the ball and AB is a third, and we don't know the restitution between the ball and BC. So this is what we're going to do to start with. Now, we know that the ball loses half of its kinetic energy in the first impact. So let's just do a tiny bit of labeling. Let's call the final velocity of the ball after the first impact W. And that allows us to form an equation, okay? Because we know that the initial KE times by a half equals the final KE. Okay, because it loses half of its kinetic energy. Okay, so let's turn that into an equation. A half times the mass of the ball, which we don't know, so we're just going to call it m because it's going to cancel out, times the initial velocity squared times a half, because it loses a half, is equal to a half times the mass times the final velocity squared, like so. Now what we can do is we can cancel out the half m as always, and we get that w squared equals a half v squared. So w equals root 2 over 2 v. We're only interested in the positive root. Therefore we can replace this w up here with root 2 over 2 v, like so. Now, if we do a little bit of resolving, okay, we know that the parallel component to AB of the initial velocity is v cosine theta, and that doesn't change. So the final component is still v cosine of theta. And the perpendicular component is initially v sine theta. So to work out the final perpendicular component, we need to multiply it by e. So it's going to be a third v sine theta. Now, if we look at this triangle here, okay, we know that the hypotenuse is root 2 over 2v, the adjacent is v cos theta, and the opposite is a third v sine theta. So we can use trigonometry to say that root 2 over 2v squared equals a third v sine theta squared plus v cos theta squared, like so. And let's just solve this equation for cos theta then. So we get a half v squared on the left equals a ninth v squared sine squared theta plus v squared cos squared theta. Now what we can do, cancel out the v squares, like so. So we get a half equals a ninth sine squared theta plus cos squared theta. And we will turn that sine squared theta into a 1 minus cos squared theta. So we get a half equals a ninth minus a ninth cos squared theta plus cos squared theta. So we get a half equals a ninth plus 8 over 9 cos squared theta. So now I'm going to take away the ninth from both sides. So you'll get 7 over 18 equals 8 over 9 cos squared theta. Cos squared theta divided by 8 over 9 equals 7 over 16. So cos theta equals plus or minus the square root of 7 divided by 4. Now, we get plus or minus, however, there's an important thing up here. Theta has to be acute for this diagram to work. If theta was coming in like this, okay, it would bounce this way and it wouldn't work. This diagram wouldn't work. So theta has to be acute, and if we look at cos theta, okay, when theta's acute, it's in this region here, okay, and that's positive. So we know we have to take the positive root. That's cos theta. And part B says the ball loses another half of its kinetic energy in the impact with BC. Find the value of E, which is the restitution coefficient between the ball and BC. So if we look up here, okay, we can see that after the first collision, the velocity of the ball perpendicular to BC, i.e. parallel to AB, is v cos theta. So that's going to hit BC and rebound, and that's going to be affected by the restitution coefficient. And that's what happens is when it's perpendicular, it gets multiplied by E. So v cos theta, which is this velocity hitting BC perpendicular, is going to become EV cos theta, like so. And a third v sine theta is a component parallel to BC. Now what happens to that? It doesn't change because it's parallel, so there's no impulse on it, it doesn't change, and that still becomes a third v sine theta, like so. Now this gives us the two components of the final velocity, so we can actually form a kinetic energy equation just using that. So let's have a look. we know that once again, the final KE equals a half of the initial KE, okay, because it loses another half of its kinetic energy. So let's turn this into an equation. Well, the final KE is a half times the mass times the velocity squared. Well, the velocity is the square root of its two components, EV cos theta squared plus a third V sine theta squared, and we have to square that. So what actually happens is the square and the square root cancel out, so we just get that. So that's the final KE. Now we need to make that equal to a half times the initial KE, a half times m. And what is the initial velocity? Well, the initial velocity is root 2 over 2v. So that's root 2 over 2v squared. So this is the equation we get, and that is a 2. So let's start working on this. Well, the first thing we can do is cancel out the a half m. Okay, like doing that. We can always do that when we're equating kinetic energies. So let's see what we get. We get e squared v squared cos squared theta plus a ninth v squared sine squared theta equals a half times a half v squared, so a quarter v squared. Now what we can do is cancel out the v squares, like so. And what we'll be left with is this. Now what we can do is we can replace cosine and sine of theta in the equation, because we know what they are. We know cos theta is a square root of 7 over 4. And sine theta, well, we can work out sine theta by using a triangle. Okay, so cos theta is a square root of 7 over 4, which is the adjacent over the hypotenuse. Now, if we use a little bit of trigonometry, okay, the opposite is going to be the square root, 4 squared, take away root 7 squared, or 7, and that's just going to be 3. And sine theta is opposite of hypotenuse, so sine theta is 3 over 4. So let's plug these in. E squared times root 7 over 4 squared, so 7 over 16, plus a ninth times 3 over 4 squared equals a quarter, like so. Now let's tidy this up a bit. So 7 over 16 e squared plus, well, a ninth times 9 over 16, so that's going to be 1 over 16 equals a quarter. So let's take away that 1 over 16, so 7 over 16 e squared equals 3 over 16. Cancel out the over 16, so 7e squared equals 3. So e squared equals 3 over 7, and e equals the square root of 3 over 7, obviously taking the positive root. So that is our final value of e. And you can also express that as root 21 over 7 if you like, both are allowed. But being precise, it does say the exact value, and that's important. You couldn't give this as a decimal.